Okay, let's see if things start getting better or worse. Yeah, thank you very much for coming. I'm really happy to see such a big crowd that seems to be interested in this topic. I am a Linux kernel developer, and so obviously I prefer to speak about the Linux kernel. Nonetheless, most of the things I want to say are pretty generic, so you can apply them to whatever open source project. It's more or less some observations about patches and how they are dealt with in open source projects. So while this talk is kernel focused, try to see the general bits in that. I have a few assumptions about you because I think I have quite an educated audience here. So I will hope you have some experiences in hacking with source codes and are somehow able to read a little bit unified diffs, because I will have some of them in my slides. And one thing I want to mention is about your devices. I know it's getting pretty complicated having mobile phones and DEC phones and all this with you, but please make sure that during talks they are muted. If they are ringing during the talk, this is at least irritating for the speaker, and I'm also sometimes in the audience, and I thought this was pretty annoying during the first day, so please mute them. One disclaimer, I am, of course, as the title suggested, I'm going to present bad and ugly patches, but I don't really want to do bashing. That does not mean that I think the people who created these patches are bad and ugly. Not necessarily. There are lots of causes why patches can be in such a state, and surprisingly this is not too different from what happened in open source projects and in companies. There might be big companies who have policy issues about not doing open source, but there are also smaller companies who'd like to contribute and face the same problems like amateur developers or open source projects. That very often it's just a too high workload, or they have to create a patch as a side effect to focus on another thing, and then they don't have time to clean it up, or they work on some hardware, get a new gadget, and then the old gadget is not interesting anymore and they couldn't finish the old patch. All this stuff happens, and is one reason why we have patches which need a bit further love or a bit more attention. And yes, there are also bad coders, but we won't talk about those patches too much here. So this is not about bashing, yet this is about improving the situation. I want to mention a few projects I encountered. First one is Osmocom BB, which is pretty surprising because they themselves don't use a Linux kernel. This is one of their Motorola phones they're using. It's not powerful enough to use a Linux kernel. Still, I was for a short time a bit involved in the development, and I came, when I was reading the mailing list, I found it, well, this is an excerpt of a mail thread, and there was one person saying, okay, I've got this USB cable which he needed to connect to the phone, and it doesn't work in the Linux kernel. Being a hacker, he was able to fix the Linux kernel himself, because he just found out, okay, it was a cable which has just a new USB ID, so he modified the driver to recognize this new USB ID so he could work and focus and follow his main focus, working with the phone. He sent the patch to the mailing list, and you can see it's pretty simple. It's just adding 2 lines. The lower line is he defines the new ID and put the new ID in the table for the driver, so it gets recognized. That's pretty simple. You can't really do much wrong with that. And then I asked him, hey, well, do you intend to send this to mainline? Because I mean, for you it was just a short exercise, but other people not having this knowledge, they might be really happy if, of course, the hardware gets detected by default. And yeah, he was interested, but he had not thought of this before. So he just needed a little input and wanted to send this upstream, and it was pretty, as it's a simple patch, it didn't need very much. What is of course required is a patch header having a description, what this patch does, and you need this famous signed off lines with a real name and your address, so in case something is wrong with the patch, everyone knows who to contact. This adding a new ID is a pretty simple process which happens very often in the kernel, so to be honest, it's a very, very descriptive patch description text. It could have been shorter, but even this descriptive version, as you can guess, should not take more than 1 minute or so to type in. And this guy added the patch header, sent it in, and I think between sending the patch and applying to the USB tree was a matter of a few hours. So, yeah, patches can take quite a while, but sometimes it's pretty fast. And from personal communication, I recall that this guy was kind of happy to have his first kernel. It was his first kernel patch accepted, and so, yeah, he felt good about it. So this was an example, a good example of the patch flow, how it went out of the original project and went to where it belongs to the upstream project, namely the Linux kernel. If you want to do that and don't know these tools yet, I want to do a short recommendation. The first one is a famous check patch Perl script, which checks for typical flaws. Please use that, even if you're an experienced kernel hacker. It's so easy to get some white spaces wrong, and so just run over it and have your patch checked. And what's really useful is if you don't know who is who in the kernel community and who to send patches to, there's the get maintainer Perl script. Just pass your patch file to that script, and it will print a list of mail addresses to whom you should send the patch to. If you work more with them, it makes sense to have a look at the command line options, but meanwhile they have pretty sane defaults, so if it's just if you use it occasionally, you just use them like here without any options, and they will give you reasonable results. So that was what I think was a good example. Somebody hacked something, it was worthwhile adding to the Linux kernel, and he took the necessary steps to do that. The next thing is the Zipit Z2 kernel. The Zipit Z2 was, oh yeah, I think in 2007 or something. It was a small device intended for instant messaging everywhere, so it's a small PX8270 based, ARM-based mini computer, I think this size. It has a small display, keyboard, Wi-Fi. Well, there's lots of devices like this around, but a few years ago they were sold pretty cheap for like 10 euros or $15, and you could get heaps of them. And they are quite easy hackable, which makes them interesting devices. And they have some support in the mainline kernel, these devices, but it's a bit rough. So there's an extra kernel around in the net to make it run more smoothly. And in that kernel, I found this patch, where you can see, if you read the description, mentions that if it is not applied, the device will crash if you use frequency scaling. And of course, you want to use frequency scaling because it's good for battery. And this is why I think it's a bad patch, because it's not in mainline. I really want to be Linux the kick-ass operating system that you can, if you want to hack something and be creative with a device, and I want the Linux kernel to just grab it and work as good as possible, so you don't have to spend on fixing things, but concentrate on what you want to do with the device. So crashing randomly is really not what I want the Linux kernel to see. That makes it, in my opinion, a bad patch. It should have been upstream. Again, no bashing. This guy has found other issues while working on this Zipit device and got quite of them upstream. but I think after some time he went to the next device or whatnot, so this patch is somewhat stalled. Yet it would be nice to have upstream. If you look at the patch, okay, it's mainly about changing one entry in the table. You see here a row of ones, which means use the fast boss method. We don't need the details what this means. And here's a row of zeros, so that means disable that, so we have a stable system. So not really rocket science. What does it need in this case to get this patch upstream? In case you let's assume you bought the device and you want to prepare a good kernel for that, and you find the patch, and my hope is that you also get the idea, hey, why it's not upstream, it should be there. So what is needed to do that? First one, of course, check if it's still needed. Mostly those kind of kernels are a bit older. I think this latest version from the Zipit archive is 3.7. Remember, we're approaching 3.13, so it's probably already 2 years old. So rule number one, check if it's still needed. It might be that it found a similar patch, a better patch, and whatnot, has already found the way upstream. If you search for the patch, if it has been submitted already, which is also a good idea, then you'll find out, okay, it has been submitted already, but there were issues with it. And what this patch does, it disables fastbus for all PXA270 boards, which sounded a bit too aggressive because for most other PXA270 boards it worked perfectly. So what was more or less requested for this patch is to extend it, to make it more optional, to say, okay, I have this board, it is known to not work, please disable it now. That's not a lot of code, but it has to be done. And that would be a useful option, because I'd be lying if the PX270 would be a state-of-the-art processor. It's pretty old by now, but it has been deployed quite often. So if you're buying cheap, old, hackable devices, you still have chances that it might have that SoC. And then if such a patch is applied upstream and another person discovers, hey, I have random crashes, then it might be, then this person might easily find, oh, okay, there's another board which disables fastbus, maybe I need to do that too. And a lot of engineering debugging effort is saved, because otherwise this person would have to do this again. And random crashes are really pain in the ass to debug, so that would be a good thing. So another thing would be nice here to extend the patch, test it on real hardware, does it with things I want, update the patch header slightly, send it upstream, and be around for questions. Might be that people have other issues raised, maybe it goes in without any complaints, just be around and don't disappear like the original patch author did, for probably valid reasons, I think. That would be a way how to make this bad patch a good patch, because after that it would be upstream. This is one example of patches you can find in repositories like a Zipit Z2 kernel. OpenWRT. In the past, meaning really a few years ago, they had a reputation of not having a lot of interesting patches and not upstreaming them. That has really, really changed. They have become very good at upstreaming, yet they have really a lot of patches, and not enough manpower to upstream them all on their own. Some may be craft, some may be interesting, so they need support for that. So if you happen to work on OpenWRT and have a kernel which is patched, it might be worth looking, okay, what patches do I have, and is there something worth upstreaming? Is there some hackish patches? I searched for some examples. This is Okay, an ugly patch, and I want to extend my disclaimer. There are some ugly patches in the OpenWRT repository. Not necessarily all of them are ugly, but for educational reasons, I concentrate more on the ugly ones. Now, please don't get the wrong impression about OpenWRT. And here you see that a patch which simply erases a data structure, initializes it to 0. And what really makes this patch ugly, there's no patch description and there's no patch author. This is a pretty simple patch, so it's not that bad, but we will see that it can go a lot worse. So this is one thing which really needs to be fixed, and it's kind of a trivial patch because the data structure is allocated on the stack, and then some values are initialized, and then it's passed on to some Linux kernel function. And to ensure that all the other unused fields are 0 is good programming exercise. So from a simple review, this patch makes perfectly sense and should be upstream too. What it needs to be a good patch is check if it's still needed. I can tell you it is still needed. I looked that up already. Look for improvements. Yeah, well, it's a trivial patch, but still I would replace the character \0 with a plain 0. I think that's more readable, but that's your decision. If you take over the patch, such things are your decisions. Since it's fixing a programming flaw, a wide-known programming flaw with an easy fix, there's an uninitialized data structure and we're initializing it to 0. It can be argued if you can leave out the test on real hardware because it's so simple. Some people argue every patch should be tested on real hardware. I leave that up to you. If somebody would send it to my subsystem, I would accept it as is because I think it's obvious. What really needs to be done, of course, as said before, add a patch header, which for the Linux kernel and meanwhile quite some other subsystems is adding a patch header with a one-line description and then a multi-line description and the signed off byline. Once you get used to that, it's done really in a minute, and then send it upstream. As mentioned before, if you use the Perl script get maintainer, it will present you whom to send it to, and this makes it pretty easy. And then we have a cleaner code in the Linux kernel. The OpenWRT project loses a patch which it has to maintain, and you, well, get credited for having a Linux kernel patch if that gives something to you, or you have a better operating system if that gives something to you. Next patch from OpenWRT is somehow a little bit similar to the USB patch, because what it basically does, it adds detection for some flash types, NOR flash types, and it defines the IDs and extends the array of parameters these flash chips have. Since we want to support as many hardware as possible in the Linux kernel, this should be upstream, of course, as well. So what needs to be done here? Check if it still applies to the recent kernel. You should probably have guessed that. And here also I can tell you, yes, it still applies to the recent kernel. So we want this up. We can upstream this, and we want upstream this after we checked if it's the best solution. This is an encouragement to work, to not blindly send patches upstream without knowing what you're doing, but also to work into the topic a little bit, because you could find out that most NOR flash chips have something called CFI, Common Flash Interface, and usually this is enough to auto-detect, so you don't have to add anything to the probe function at all. So if you have the hardware, you could check if it still works without the patch and the CFI interface is enough. You could find out then that the CFI interface in that flash chip is broken and you really need the patch. I also added some flash chips because they advertised something which they did not do in reality, and so we had to add this manual detection instead of the automated one. And this is something which could be done here as well. It's fun hacking, in my opinion. I like hacking with embedded devices and getting chips to work and reading registers and stuff like that. And once you did all this, again, add the patch header. Here, we really should test that on real hardware. This is, I think, too advanced for an educated guess, so make sure it works on hardware. And again, send it upstream and be around to answer questions. That sounds like a long list, but I don't think it's really that long. Depending on your experience, this might be an hour or 1 or 2 evenings of hacking and fiddling around, reading data sheets. And then we have support for new flash types. Well, next board you hack might support them automatically. Might be good. This is a patch which in my opinion is really ugly because I don't have much knowledge about this subsystem. I don't know. My experience is in drivers, device drivers, especially I2C, where I'm the maintainer of the subsystem. Okay, this is about PPPoE. I don't know much about the internals of that one. What I see here is that there are 2 places where some memory is allocated, and the patch extends the amount of memory allocated. So my first guess, it wants to prevent a buffer overflow, which I think is very, very important. And here it's really, for me, it's really annoying there's no patch description. I don't know, is this a proper fix? Is this a hacky workaround? Or is this something OpenWRT specific because they hacked something else somewhere? And in order for me to find out if this is a bug fix, I basically have to do all the engineering work again to find out what the status of this patch is. So this is why I think this patch is extremely ugly. When I work commercially, it's also sad true that sometimes you get patches exactly like this. You have no idea where they came from. There's nobody you could contact, and you have no idea if this is important or rubbish. So what do you need to make with this patch? Check if it still applies. Maybe someone else has already fixed the same problem and has a proper commit message so you could understand what's going on. I can tell you it still applies to the current kernel. So if it's an issue, if it's a bug, it's still open. Check what I just mentioned. Check if it's a workaround, a custom case, or an important bug fix, or related to that, check if the patch has dependencies or if it's a standalone bug fix. And if you found out that it's something which should be upstream, again, add patch header. I'll leave it up to you if you test it on real hardware, send it upstream, and be around to answer questions. And yeah, those are, if it's really a bug fix, and then it fixes a buffer overflow, and it should be so upstream. So if anyone of you is familiar with that PPPoE interface and actually knows if that is a bug fix, please hurry up. What I also want to mention, this is not black and white, it's not all or nothing. I know that the same what I said in the beginning might apply for you. You just stumble over the patch, but you have something else in your focus, so you don't really want to spend too much time on upstreaming a patch you're not mainly interested in. That's what I think where small steps add up. So if you just happen to know that this is a bug fix or can say something about the patch which has useful information, just add the patch header and send this a patch to OpenWRT. That won't make the patch immediately go upstream to the Linux kernel, but it will help other people to understand what's going on with that patch. And I really, really think that just adding a patch header is definitely worth a commit and not only changing code. Sometimes people ask me how to get into Linux kernel development, and I think this is a good way to start. I mean, OpenWRT supports a lot of devices, and a lot of them can be bought for very, very little money these days on auction via auction sites. And it's a good way to get into kernel hacking by just buy one such a cheap thing, get the version, kernel version which is inside OpenWRT, get it running, and then try to upgrade the kernel to something more recent, even the most recent. This can be some work, which is sometimes needed to test one single patch. Then you find out, oh no, I have to port the whole platform. This can be extra work, and it can make you go away. But if you're interested and said, hey, I want to learn something about Linux, especially embedded Linux kernel development, that's a really good way to learn things. So I can recommend that. What I have not talked about, there are nightmare patches too. You usually get them from chip vendors. One thing where you can easily detect them, they're like 1 or 2 megabytes in size and patch everything at once. So with that, you have really a different set of problems. You split up into separate chunks, decide on each chunk if it's useful or not. This is a nightmare, and they often contain useless changes, fixing white space, adapting to some personal coding style, making everything look different for nothing. But let's start with the lower hanging fruits, from which I hopefully showed you some, and hopefully presented you some ways to do that. So I hope that more patches are coming upstream. And one thing I also want to mention, if you create patches, think about sending them upstream in the first send, make them good patches, or at least make them not ugly patches and describe them to some extent so people later can pick them up and do something more useful with them. Yeah, that was the condensed talk in half an hour. That's what I wanted to give you from my experience. I really wish you a happy hacking, because in my opinion it's great fun, and if you have questions, I think we have 1 minute left. And feel free to meet me somewhere here at the conference. I will be here till the end, or write me an email. I'll be around. And if you leave the room, please try to be quiet so we can hear the questions if there are any. Does the internet have questions? Nope. Somebody here? Nope. Okay.
Alrighty, thank you very much. We already gave one from a warm round of applause.